Hi everyone, my name's Shay Newton. I'm the maintainer of an open source project called Open Source Car Control that is a solution for by-wire control of certain Kia vehicles. So you bolt this into your car and to your computer and you can actuate steering, throttle, and brake. I wrote a tool to help validate that in Python that communicates with OSCC over something called the CAN channel, and it communicates with the car over the car's CAN bus. And we're going to talk a little bit about that today. So the talk, Can We Talk Python, is about talking to your vehicle over the CAN bus. So what is CAN? CAN is a message-based communication protocol that's ubiquitous in automotive spaces. It stands for Controller Area Network. Your car is constantly buzzing with traffic on the CAN network. Whenever you use an electronic system, there's CAN messages flying around. So when you roll up the window, if it's an electric motor, when you press the gas, when you flip on the windshield wipers, this is your car's. Your car is just communicating like wild over the CAN bus. And with projects like OSCC, we tap into this. There's some hardware required for talking to your car with Python or with C or whatever you use. So this is an example of just some of the hardware you need. There's varying kind of price requirements, and there's different protocols that you can use if you want to do something similar. But yeah, we're gonna go with CAN. This is the hardware I used preparing for this talk. Okay, standard CAN frame. There's something called extended CAN frame that we're not going to get too deep in, but standard CAN frame is mostly this. If you Google CAN frame, there's some wild diagrams that are more complicated than I've ever had to get in a couple years working with CAN. Basically, there's an arbitration ID that defines the message. So if you're listening to a lot of traffic on the bus, you can say, I'm looking for 123 and find it relatively quickly. There's something called a DLC, which is a data length code. For standard frames, this is usually 8 bytes. If it's less, you know not to look further. If it's more, you know that you need to troubleshoot your system because it shouldn't be more than 8 bytes. The data itself is literally just raw bytes. You've got 64 bits. This is just arbitrary hex counting from 2 to 64. But when you're unpacking CAN data, you're looking at a packet that looks something like this. So this is a visualization of a single CAN frame from a Kia vehicle. I think it's a Kia Niro that represents wheel speed measurement. So this CAN frame is color-coded by byte over the period of about 13 seconds, and it's the car going from 0 to 20 miles an hour. This is just the CAN frame itself having wild activity. You'll see this kind of strange rise and drop where it should be continually increasing, and it's because of integer overflow. You only have 8 bits in your byte, and the value for wheel speed is 12 bits. So there's some magic that you have to do to take the bytes and get yourself the value. So I've got kind of a reduced example of what it looks like in Python to get your 12-bit value out of 2 bytes. It's got some anding and shifting and ORing and a kind of scale. But this is the kind of thing that typically when you're introspecting and you're looking into the vehicle data that you generally will have to be hacking around with, hacking on bits. So I kind of agree with Merriam-Webster that hot dogs are sandwiches too. But it's kind of to say that I think that in Python, if you've done file I/O, you can read and write to the CAN bus. It's basically as simple. With file I/O, it's kind of open, read, write. With CAN, it's instantiate, send, and receive. Python just makes that beautifully simple and clean. So without something like OSCC, there's a channel into the car that the car's CAN bus that's accessible to everyone. It's something called the OBD2 port. OBD stands for Onboard Diagnostics, and modern cars use a second revision of this standard. And it looks something like this. So this is a picture that I took last night of my car. The OBD port is generally to the lower left of your steering wheel. Sometimes it'll be where this ashtray is in my car, but it's something you can bolt right into. So OSCC uses the OBD port. When you take your car to the mechanic or dealership and they troubleshoot it or they make sure that the car's in good shape, they'll plug into the OBD2 port. When you take your car to get emissions tested, they plug right into it. There's newer technology that does some sophisticated things with it. There's a tool that has a Python interface called Panda, I think, that gives you wireless access to that data. I just saw something pop up called T-Mobile Sync Drive. That's pretty wild. That plugs into the OBD2 port and gives you a wireless hotspot, but I think it's also monitoring your driving data. I don't know where it's going necessarily, but it's the OBD2 port in action. So when you plug into this OBD port, or most of the car's CAN channels, there's just wild amounts of chatter, just lots and lots of activity. So other things that you might see are context around error states in your car, warning lights that are on, timing data, how long the vehicle's been running since engine start, temperature of oil and coolant, lots of things that validate what your dash says, right? You can pull for odometer readings and RPM, engine RPM, that kind of thing. So this is a link to a project I put together for this talk specifically. It's a tool that you can, with the right hardware, plug into your computer, plug into that OBD2 port, and get a few key pieces of information from the OBD2 port. So what this tool does is queries for what OBD standard the vehicle conforms to, because there's a handful across different auto manufacturers and regions. It checks to see how much gas you have in percentage, and it checks the time in seconds since the engine was started. And what it does concretely, this is a little hairy, but it kind of hopefully will illustrate my point that you initiate your CAN bus, you set up some data, you create a message, send it, and receive, just pull for it. So in 23 lines or so, you're talking to your car with Python. The Can We Talk project was written to be a little bit more bare bones, just so you could see, if you're interested in exploring kind of the raw read, write, initiate kind of logic. But also for OSCC, I'm a part of a tool called OSCC Check that you can also check out that has a little more abstraction, and it does things like talks to OSCC and asks it to actuate steering, like give it directional torque, and then check to make sure that the vehicle steering wheel changed in that direction, or apply brake pressure and check to see that the pressure corresponds to what you're looking for. And if you're looking into that tool, you'll see things that are a little more, just a little cleaner for users who want to hack on it and that are using OSCC specifically. So you'll see just initiate the bus and check wheel speed, which under the hood is doing something similar to that kind of byte hacking that we looked at earlier. So the CAN bus in your car, ideally, some takeaways from this talk. The big one is that Python does an amazing job at talking to your car. It's got a rich ecosystem, and talking to hardware is no challenge for like Python. There's amazing libraries for it. For my tools, I used a tool called Python CAN. It's pip installable, and it wasn't any harder than that. There's a second takeaway if I'm lucky. It's that your car talks over a CAN bus, the controller area network. And I'd like to also just re-cement that I do think that hot dogs are sandwiches too. I think, yeah, everything's a sandwich. And I'm open to questions if you have them.